find intervals where this function, in example 8, find intervals where this function is increasing and where it's decreasing. So you can see from the answer here, it's increasing. I'll use the same color that they've used. It's increasing from here up to -1. Okay, so we say for x is less than -1, it's increasing. Less than or equal to -1. Okay, it's also increasing from +2 to infinity. So we say when x is greater than 2, it's also increasing. It's decreasing between -1 and 2, -1 and +2, and so we say that. Decreasing between this interval. -1 is less than or equal to x is less than 2. So back over here when we look at these sign diagrams, we've got our original function, f of x equals x squared. The derivative is 2x, and we can draw that sign diagram. The 0 is 0, okay? And if we choose a number smaller than 0, say -1, we would get -2, so that's a negative number. Choose a number bigger than 0, we'll get a positive number. Okay, this now tells us, okay, this is a sign diagram of the derivative function. Keep that in mind. This sign diagram is of the derivative function, but it tells us whether the original function is increasing or decreasing. Okay, so the negative sign represents a decreasing function on our original function. The positive sign represents an increasing part of the function, increasing interval on our original function. Let's look at the rest of these examples. We've got here f of x equals -x squared, and this is what the graph looks like. The derivative of that is -2x. We can draw a sign diagram very similar to the one above, but here it's positive and here it's negative, which means that our original function over here is increasing up to 0 and then decreasing bigger than 0. f of x equals x cubed. This is what the graph looks like. The derivative is 3x squared. We can draw a sign diagram of that derivative. We have a 0. There's no asymptote. 0 at 0. There's no asymptotes. And that function is positive even when x is negative. The function is positive. When x is positive, the function is still positive. That function is increasing up to 0, and it's still increasing again from 0 and bigger. And the last one here, f of x equals x cubed, subtract 3x plus 4. The derivative, 3x squared, subtract 3. Now we would factor that here to find the zeros. Here's our zeros, -1 and 1. And we draw the sign diagram of this derivative function. Okay, this derivative function is positive in this interval, negative in this interval, positive in this interval, which means that the original function is increasing in this interval, decreasing in this interval, and increasing in this interval.